All right, so now that we know what a rate of change is, the last couple of examples we did in those videos, some of you probably said, hey, I've seen this before. And you have, because there's a very famous rate of change that we know as slope. So let's take a closer look at it, and then we're going to calculate a bunch of slopes. So slope basically is a situation when we are talking about my change in y over my change in x. Y being vertical change, we're talking about the change in my vertical location, and x being the horizontal movement, right? We're talking about the change in my horizontal movement. So this usually happens when we're moving from one point to another point in our xy coordinate system. So as we move from one point to another, there's some horizontal movement, change in x, and then there's some vertical movement, change in y. So that's the way I like to kind of think about them. Note that the change in y is always up in the numerator and the change in x is always in the denominator. You guys have probably famously, seen this as rise over run. And I'm going to put the run in parentheses and the rise in parentheses because, rising, we're not always rising. Sometimes we're actually falling. So it's a vertical change, right, over a run, right? We're not always running to the right. Sometimes we're running to the left. So it doesn't really matter which way we go. We're talking about horizontal movement left and right, or we're talking about vertical movement up and down. All right, and so that's why I kind of prefer saying vertical change over horizontal change, or change in y over change in x. One last thing too, for the word slope, we actually use the variable or the constant, if you would, m. And so you've got that guy right there. And so we find that m, right, if you go back and look in your your dictionaries, right, I think the reason why we use the variable m or the letter m is because of the word mantissa. If you look that up in the dictionary, that is what the Greeks used to call slope. All right, so m equals the change in y and the change in x. All right, and so we're going to find that there's actually two ways to calculate it. And so let's go ahead and look at that now that we have a definition for a similar problem. So we're going to find the slope of a line that passes through the points -1, 4, and 2, 6. And so a couple of ways that we can calculate that slope is one is using a famous formula. All right, that famous formula you guys probably know as y2 minus y1 over x2 minus x1. And what I'm getting at here is there's two data points we're moving from, right? We're talking from one data point that's called x1, y1, and another data point that's called x2, y2. So if I know those two pieces of data, just like we've used formulas in the past, I plug them in. So this is our slope formula, right? Make sure you memorize that, get it in your head. So if I was going to use the slope formula to find the slope, right, I'd have to identify, well, who do I want to be the first point and the second point? Well, why don't we just go in order, right? So there's x1 and y1, which makes that x2 and y2. So plugging my information, my slope would be my y2 value, 6, minus my y1 value, 4, and then on the bottom it's my x2 value, 2, minus my x1 value, -1. And so doing the math, 6 take away 4 would give us 2. When I say 2 take away -1, that's 2 plus 1, and so we get 2 over 3. And so this is basically saying that for every horizontal change of 3, there's a vertical change of 2. So yes, we're moving up. And that's kind of getting me to the next way we're going to calculate slope. Again, it doesn't really matter. A lot of students get worried about who's who here. And as I shared with you in the rate of change, just be consistent in how you're subtracting. If you wanted to, we could have called this x2 and y2 and this x1 and y1. And so the slope formula now would look like this. It would be 4 take away 6 and -1 take away 2. And upstairs we would have gotten -2, and a -1 minus 2 would be a -3, and then a negative divided by a negative is a positive, and you still come out with 2/3. So just be consistent, as we saw in the rate of change. Make sure your data point is being subtracted from another data point. Be consistent. So there's your formula. Of course, we could also visually count. And that would mean if we're going to do something visual, I need a graph. So I'd have to come to my grid, and here's negative 1, 1, 2, 3, 4. Right? So there's negative 1, 4 on my graph. And then the other data point is 2 and 6. All right, so there's 2, 6. And so now what I'm trying to do is visually just count what is my rise and what is my run, or what's my vertical change and my horizontal change. So as we move from this point to this point, we're going to first move, and it doesn't really matter if you move first vertically or horizontally, it's all going to be the same. But you can see that my change in x that I went through as I moved from this point to this point, we went along the x-axis 3 times. And then what's my rise, what's my change in y? Well, as we moved up, we went up 1, 2. And so my slope is change in y over change in x. And what we get is 2/3. And again, it doesn't really matter how you calculate it. If you wanted to go up first, right, we're still going up 2. And if you wanted to go run second, we're still going over 3. So my change in my y over my change in x is still 3. So it doesn't really matter how you calculate it. So there's a visual way to see slope as we visually move up, and or if we rise or we run, or the slope formula way where we create a data point x1, y1, and x2, y2, and we just dump the information in like we would with any formula. So there's our definition. Here's a couple ways to calculate it. Well, what we have to do is practice. So that's coming up in the next couple of videos.